Today, I'm pleased to introduce today's session, What Makes Deep Research, a dive into AI agents, and our guest speaker, Stefan Webb. Stefan is a developer advocate at Zilliz, where he advocates for the open source vector database Milvus. Prior to this, he spent 3 years in the industry as an applied ML researcher at Twitter and Meta, collaborating with product teams to tackle their most complex challenges. Stefan holds a PhD from the University of Oxford, and he has published papers in leading machine learning conferences such as NeurIPS, ICLR, and ICML. He is passionate about generative AI and is eager to leverage his deep technical expertise to contribute to the open source community. Welcome, Stefan.
Thanks so much, Sachi. Thanks for the kind introduction. And you're right, I'm very passionate about generative AI and also passionate about helping developers. So I really love doing webinars like this, meeting some of our users and people just interested in vector databases and generative AI. So just like a tiny bit more about myself before I get started. So I'm what's called a developer advocate for Zilliz, the company behind the leading open source vector database, Milvus. And so as a developer advocate, I serve as like a bridge between developers, the users of Milvus, and the developers. So providing technical support to users, helping connect users with engineers for deeper technical support. Also running a lot of events like these webinars. We do a monthly meetup in the Bay Area, and producing some written content as well. So I've put my LinkedIn there. I always love connecting with new folks. I love hearing like what you're building with generative AI, hearing like what your sort of like challenges are and what your visions are. That's like my bread and butter. So please connect with me on LinkedIn. I would love to hear from you. And maybe like if you're building like a RAG or an agentic system with your startup or your company, I think there's a really good opportunity for a developer advocate at a company like Zilliz to sort of help and provide some consultation. So with that, let's get started with the webinar. So the topic for today is what makes deep research? And I've subtitled it a dive into AI agents. So we're going to be talking about research agents specifically. But I think a lot of this sort of also relates to generative AI agents in general. So I'll start off, I'll just sort of like give a tiny bit of background to OpenAI's deep research release. And then I'm going to introduce a research agent that is open source, inspired by that, produced by engineers at Zilliz and fully open sourced. So I say demo, it's more of like a code walkthrough. I'll sort of like explain how it was put together. Then after that, I'll talk a bit about some of the ideas behind agents in general, but also research agents and what's kind of like new and why has deep research sort of come on the scene so recently. And then with that discussion, it should be like clear like what some of the challenges and I guess like challenges and obstacles to wider adoption. So we'll talk about some of those and some potential solutions. So sort of gives you a sense of where things are headed over the short term, next 6 months, 12 months, etc. So with that, let's get started. And so by the way, feel free to ask questions in the chat as they occur to you. And I'll just kind of like, I'll stop whenever a question comes in, or try my best to do so and take them as they come in. So, okay. So I'm sure like everyone here has heard about OpenAI, one of their new product releases, Deep Research. which was released at the very or near the start of February last month. And so this is it's a bit of a different product to their sort of like straight chatbot in that so it is able to go off, search the web, use other sort of like tools to build a really detailed report to your question. And so you can give it, so I've just taken a screenshot here. And so this is an example. The question in this case might have been, please research freestyle snowboards suitable for an intermediate rider with, and then the user's given some details, their height, their weight, shoe size, etc. So then this agent goes off, searches the web, and is able to sort of work out how to answer this question, sort of like iterating from one step to another. And then after some time, could be like 8 minutes, could be 30 minutes, synthesize like a really detailed and coherent, informed report. And so this is like much different from the sort of plain old ChatGPT that is just like, like returning you an answer more or less in real time rather than sort of like going off and going through like a lot of autonomous steps. So I think, excuse me, why this sort of like exploded in the media was because people were really impressed by the results. It seemed to do a very good job of actually researching a topic that might require not just like a plain answer, but might actually require going off, looking at multiple sources, asking further questions. And I think I read somewhere, one sort of professor was like, this sort of, could replace like an early stage PhD student in terms of doing some research. And other professionals were just like really impressed with the result. But what exactly was new about it? Well, it wasn't the first research agent released commercially. So Google's Deep Research was released about a month earlier in December. What exactly was new about it? Like, why did it sort of, what was it about it that had this really much superior output qualitatively? And I think the answer to that is we're not really sure because it's closed source. It's sort of like tightly guarded secret, the design. But from like, the sort of rumor mill, I suppose it's like people speaking to insiders, plus also like the blog and announcement that OpenAI released. It seems like a big sort of element of that was that it focuses on like an end-to-end training with reinforcement learning on really high quality reasoning trace data, which we'll discuss more in a minute. But again, possibly there's other things in there in the design. We just don't know because it's closed source, but we can kind of like guess what they are by trying to like reproduce a system that can achieve similar results on the benchmarks they were using. And so one such model is from DeepSeek. So DeepSeek R1. We'll talk about that a bit later on. Okay, so what exactly is a research agent, and how does a research agent differ from just like an agent in the general sense? And I think it's like one of those things in generative AI. People disagree on the definitions so far. We're still sort of like coalescing around an exact definition. But my definition, which I think overlaps with many people, is it's an agent that, so the goal is to to do research in the sense that it has to go off and discover many relevant sources. So it's not just like doing a single lookup to a vector database, or it's not just accessing like a single Wikipedia page. It's pulling in, it's making a decision about various sources to search, and then break the question down into multiple steps, and sort of have autonomously sort of like reason through answering the question, and then synthesize like a detailed report at the end. And so I got some quotes here from the deep research release blog, and I sort of like saw like three themes. So we've got iteration, we've got search, or I guess we talk like tool usage, and then the third is reasoning. So under the topic of iteration, so the deep research release blog post, it mentioned, well, it had described things like learn to plan and execute a multi-step trajectory. Also backtracking and reacting to real-time information. So this is obviously like describing like like an agent that is able to sort of know what to do next autonomously. Also pivoting as needed in reaction to information it encounters. So a second thing, and I think these are sort of like, there's a overlap between these three, but under the topic of search, the blog post contained things like train end-to-end reinforcement learning on hard browsing and reasoning tasks across a range of domains. And I think it's generally sort of like supposed that this is kind of like the main secret sauce ingredient. Also optimize for web browsing and data analysis. And then on the third theme, which overlaps with iteration search, is reasoning. So fine-tuned on the upcoming OpenAI O3 reasoning model, and it leverages reasoning to search, interpret, and analyze massive amounts of text. So we can sort of like piece from this blog post release how it might work, and relate that to like the latest developments happening in generative AI, and try and sort of like reproduce the results by building our own system. And that's exactly what we did. So we were very excited by the release, given the, we sort of like saw the qualitative quality of the output. And so we were really curious, being a vector database company, vector databases being one of the core components powering agents. We were really curious, like, could we build our own open source version to work similarly? And that's what we did about a month ago. Some engineers built an open source software called Deep Searcher. And so like deep research, you give it a query, it then goes off, searches through multiple sources, sort of like iterates through, breaks down the question into steps that can iterate over, finally makes a decision about when to stop answering the question, and then synthesizes like a detailed report from all that information. And so this research agent, it's built on top of the vector database Milvus, which is so Zillit's with the main contributors. It's been donated to the Linux Foundation for AI and Data since I think 2020. And so let me just say a few words about Milvus before we go into the code of Deep Searcher. So Milvus is fully open source Apache library, so suitable for commercial use, and very simple to use. You can pip install the light version on your notebook. A much sort of more scalable version, you can launch in a Docker image really easily. And then we have like a third version, which is the fully distributed version, Milvus cluster, that like you launch on a cluster of machines via Kubernetes and can scale to like literally the tens to hundreds of billions of vectors. So easy to set up, has really good integration into the generative AI tooling ecosystem. So because it's open source, we have a lot of contributions from pretty much all of like the big tools in generative AI. So whether that's like Hugging Face, OpenAI, LangChain, Gina, Airbyte, there's I would say like dozens and dozens of these integrations. So you'll be able to use it within your existing tool set most likely. And I think like a strong sort of like recommendation for its performance and reliability is the fact that it's used by a lot of really big companies. So everyone from NVIDIA, Microsoft, Salesforce, IKEA, and so on. And so just like very briefly mentioned, so I think like a big sort of use for vector databases is retrieval augmented generation, as well as what we're now calling agents, which is sort of like extensions to this framework. And so just to like make it clear, like where the vector database fits in, I've got like a schematic here of a RAG pipeline. And so you start off with a knowledge base of things that you want to search over. Oh, and so by the way, so our sort of like research agent pipeline will be like an extension of a basic RAG pipeline. So we've got our knowledge base that we want to search over. So this might be like your internal company documents. It might be like images from customers or like videos that people have uploaded. You then put that through your embedding deep neural network to produce these vector embeddings. And then you store that in Milvus. And so Milvus then provides a really convenient and efficient interface for performing a similarity search, or essentially a semantic search. So in a RAG chatbot, the user then comes along with their question. So this question gets put through typically the same embedding model. And then we search for similar vectors to the query vector in our vector database and retrieve vectors that are close that correspond to items in our knowledge base. And because of the way that these models work, those ones will be semantically similar to our query. And so in other words, they'll contain relevant information to the query being answered. So then the idea of RAG, very simple, we just put those into the context of the prompt that we run the large language model on, or large language vision model, or whatever foundation model you're using. So we augment the user's question with these retrieved documents from the vector database, put them into our large language model, and then because the large language model has that context, it's able to give a much more reliable, up-to-date answer. So you can think about it as like an external memory for the for your RAG or your agent. So an external memory that you can like update as new facts, new data come in, and you don't have to retrain your foundation model, your large language model. So I've got two links here. I think these are some really good resources if you're getting started with Milvus, or just building generative AI applications of vector databases in general. So on the right, I've got the GitHub to Milvus. So you've got instructions to download it, a link to the docs, a lot of really useful tutorials. And then on the right-hand side, I've got our generative AI learning portal, which has a lot of really useful notebooks. telling you like a sort of taking you through the steps of building much more substantive applications. So really good like resource to learn how to build RAG, agents, recommender systems, semantic search, and so on. But let's now turn to a code walkthrough of Deep Searcher to see how we actually constructed this this research agent. And I think it helps before we actually go into the code, just to have like a mental model of what it's actually doing, so that we can sort of like scaffold out. I guess like sort of keep that in mind as we're going through the code, so that it makes sense. Similarly to a RAG system, this research agent has two separate parts. The first is data ingestion, which happens in our case beforehand. So you tell it what internal documents, crawled web pages, structured data, streaming data, in theory that you want to search over, and that gets stored, that gets embedded and stored in Milvus, the vector database. So I think in like a future version, or I think it's a feature we're adding, is this sort of like more dynamic search the web as needed. So then the other part, the main part, is this online serving. So the user will come in with a query, then we use a large language model, in our case, a reasoning model, to break down the question into a number of sub-questions or sub-queries, which then a router sort of works out like which sort of like data store to fetch relevant entries from, which we then do from the vector database. And then I think this is sort of like the what makes it you can call it an agent rather than just plain RAG, is it has this reflection step that decides what to do next. So the LLM says, or the prompt asks it to answer the question, are there any gaps in the questions that have been asked and answered so far, using the information from the data ingestion. And so if it says yes, there are still gaps, knowledge gaps to be answered, then it will generate new queries, and then just go through the same process and sort of keep looping this until it's satisfied that it's either like exhausted a like a budget of iterations or tokens, or more likely before then it's exhausted all of the questions that it believes it needs to answer to sort of cover the query and not have any knowledge gaps. So this is what makes it we can call it an agent rather than just like a plain RAG. Is the LLM is being used to route the execution. And I guess we can think of this calling the vector database in response to like dynamically generated queries. We can sort of think about that as like a form of tool usage as well. So we've got this conditional execution. We've got tool usage, two sort of like defining characteristics of being an agent. And so then after that, then when it says, okay, there are no knowledge gaps, then it'll move on to the final step, which is to then use the large language model to join those answers from the sub-questions into like a single coherent final report. So, one thing I should mention is, so we're using like typically like a reasoning LLM for these steps, which I'll explain in a bit more detail a few slides on, but that's sort of something that's really useful for like improving the performance of this this reflection step. Okay, so let's go across to the GitHub and actually take a look at some code. And by the way, so don't be shy. If you have any questions, feel free to write them in the chat and I'll stop and answer them as they come up. So this is the GitHub repository for Deep Searcher. And you can see there the architectural diagram. So this is like a screenshot from output. You can see it's sort of like printing. Sort of like printing the intermediate steps, like the iterations of breaking it down into subqueries and answering those. You can see it says accelerated playback. So that's sort of one of the, I guess, like sort of the challenges of research agents currently is they're very expensive in terms of foundation model inference. So the example I'll be showing later on, I think made something like 75 queries to a reasoning large language model. And, that's why it takes like 10 minutes, half an hour, or potentially longer to actually to run through all of the reasoning steps. I actually hit the rate limit for when I was doing it with an online service. So I had to sort of do my 10 queries, wait a minute, do another 10 queries. I think a key point is like inference is really like a key bottleneck. Okay, so we got a question from Anna Ruda, which is how does the LLM know when it has got sufficient knowledge such that there are no knowledge gaps? Yeah, so it's a great question. I think this is just sort of like down to the like the magic emergent properties of LLMs. These models have been trained on specifically on reasoning, like multi-step reasoning tasks, and yeah, it's just one of the sort of like the things that the LLM can do. It's been trained on like so much data and sort of related tasks in the post training that it seems to be able to perform this task as well. So does it need to be a reasoning model? So no, it doesn't need to be a reasoning model. I think actually it would be advantageous to use some cheaper models for some of the other steps. So as you mentioned, so breaking down the subtask, breaking down the query into subqueries, I think that's something that you could have a much smaller, well, I mean, even just like a more sort of general chatbot LLM, but ideally a much smaller language model that has been like fine-tuned for that purpose. So that's sort of, I think, like one of the sort of easy solutions we can get to like speeding up the inference of these models is using sort of like smaller specialized models for each of the steps. So great question. Okay, so let's go through the code. So if you want to try this at home, you can git clone this repository, install the dependencies, and then copy and paste. So here's here's an example of how you actually sort of initiate a call to the deep research agent. So you can see here, we create like a default configuration. Then we put we override some of the options. So we tell the research agent that we want to use OpenAI as our large language inference service, and specifically, we want to use GPT-4o mini. For the embedding model, we're also going to use OpenAI's embedding service. So, but Deep Searcher supports a number of different inference and embedding services. For example, you might want to use Hugging Face's sentence transformers locally for the embedding. Or in my case, you might want to use like a distilled version of DeepSeek R1 for the large language model. Okay, so then we ingest the data that we want to search over. So in this case, we're specifying that data in advance. But as we like develop this, it'll be able to like go off like autonomously and find relevant sources. And then we just need to call this this query function here. One way, like I sort of like to sort of work out how code is working is literally just step through the functions. So like I put this into a document, I ran it. Unfortunately, I can't really do a live demo because it would take like say 10 plus minutes to give back a report. But imagine we've done that, so we know that it works. We can say, okay, let's sort of do like a step through debugging and look inside each of these functions and work out how it's actually doing what it's doing. So we've got here query from online query. Okay, so then I use VS Code. You can just sort of jump to definition. So then we see that it's calling this configuration.default searcher, and it's calling default searcher.query on that. So what is default searcher? Well, we'll have to go to the configuration and see what the is setting it to there. Oh, and so just before we go on, so we've got another question from oh, actually, no, sorry. I think I've already answered that. That's from Anna Rutter about how does it know that there are no knowledge gaps. And yeah, so that's just like I said, these foundation models, especially after they've been sort of like post-trained for different tasks like chat, reasoning, evaluation, have like massive sort of transfer learning to unseen tasks. And so I'm not sure exactly whether this task of identifying knowledge gaps was in the training somewhere, but it's just like the power of like scale and transfer learning that it can do tasks like this. Okay, so we see that when the configuration is initialized, the default searcher, it's creating this RAG router option, and then it creates. So we've got two agents in here. I think it's going to sort of like work out which one to route to, but we'll look in. So chain of RAG is like a different technique. If you're interested, you can check out this research paper that describes it in a bit more detail. But we're going to look inside the deep search object here. And so it seems like this object is going to contain the logic to perform our, excuse me, to perform this like this architecture of research agent. So let's have a look into deep search now. So I've gone across to the deep search, the file that contains deep search. And by the way, is this large enough for everyone? I'll just see if I can make the font a bit bigger. Okay. Here is the definition of this deep search object. You can see it sort of takes a number of parameters to store in the object. So it takes like a base LLM, it takes an embedding model, it takes a vector DB, a max number of iterations. So that's going to be like a limit on the number of these reflection cycles that we can do. As well as some other sort of like settings that a bit more sort of miscellaneous. So I'll jump over them. Now we know like what the object is that is actually performing the query. So I'll just go back here. You can see that this method here is going to call deep search.query. So what does that do? Well, let's go and have a look at the code. Okay, so here we are here. And so just to reiterate, so I would actually do this with a step through debugger in VS Code, just like doing, step through, stepping into, to sort of like follow the path of execution. And that just is like a really good way to understand which is like the relevant code to sort of like what code is doing what, where is like the most relevant code to understand what's going on. And also not everyone's familiar with this, but I think a really helpful tool for debugging and understanding code is the debug console in VS Code or whatever IDE you use. So when you've stopped execution in your step 3 debugging, you can actually then just type in expressions into the debug terminal. So you can type in, like what is the shape of this tensor? What is the value of this flag? Does some condition hold? And that's a really useful way for like interrogating the program as it's running to understand what's going on. But let's look at this query function. So we can see that the first thing it does is it calls self.retrieve. Okay, so I think we're sort of like untangling the execution flow of where the actual agent's happening. I think we're getting a bit closer. So now let's look at the self.retrieve function. So where is it? Oh yeah, here we go. So self.retrieve, that calls this self.asynchronous retrieve. We're just sort of like hacking through the layers of indirection to get to the core of it. And so it's going to call this, it's going to run this this function asynchronously. And now it looks like we've actually gotten to like the core logic of how the research agent works. Okay, so we start off by just like setting a variable that contains the maximum number of iterations. And so this comment here indicates that the first thing we'll do is we'll break down the query into subqueries by prompting the large language model. So that's this sort of like jump from the user's query to the first set of subqueries. And we've got a generate subqueries method here. Now that we've reached sort of like the core logic, I won't sort of jump down further until we've gone through this entire loop and we can see like what exactly are the prompts that what are the prompts that the LLM is being prompted with to do the different tasks like generating the subqueries, working out where there's knowledge gaps, and so on. Okay, so here we've got the log color print. So this is what you'll see in the terminal when it's performing this step. And then it takes the list of current subqueries and then just adds those ones to it. And so now we have a loop. So now we've sort of entered this main logic loop, this main, I'm not sure if you can see my mouse pointer, but I'm sort of like circling around this like inner loop in the online serving area of the architect diagram. So the first step is to search for relevant chunks from the vector database, given the query and the subqueries. So this is actually going to return some like asynchronous tasks. So that's this sort of like step of calling the vector database here with those queries and subqueries. So those just return tasks. They don't get executed until we call this await async.io.gather. And that actually executes the tasks in parallel and then waits for the final one to finish before setting search results. Okay, so then we take these results from the subqueries and then we merge them. And we're also keeping track of how many consumed tokens we have because we want to sort of be able to calculate the cost of this afterwards. Also, we might want to set like a hard limit on like a token budget, token budget, I should say. Okay, so then we sort of then we take these search results, put them into this list of search results from VectorDB, and I think in many cases we're going to have duplicate chunks returned from the vector database. So a good step is just to deduplicate those so that we have a list of unique chunks fetched from the vector database from those subquery queries. So this is where we break if we've reached the maximum number of iterations. But then the next step is performing the reflection and getting additional queries that can cover any knowledge gaps. So if we go back here, now you can see we've sort of gone through this loop. Now we're in this yellow-orange diamond, and we're performing this reflection step. So this is where the LLM or the reasoning model is going to actually control the execution. And then we just perform, we prompt the reasoning model with another prompt to generate the gap queries. And so this is going to generate, so if the model believes that there are additional queries that need to be answered to sort of fill in any knowledge gaps, then it will return them in the sub-gap queries. So we know that if that's empty, then we know that we can terminate that loop and then go on to generating the final report. But otherwise, we then just add those new subqueries to the subqueries. So this is sort of like a stack of queries to answer. We then add them to that list and then repeat this iteration. So we then just do another loop around here. That's essentially it. So if we got time, I'll just sort of briefly look into these functions that actually define the prompts. And hold your horses, Sachi. I've just got a few more minutes, and then I'll give some conclusions, and then we'll leave 5-10 minutes at the end for any questions. So actually, what I'll say is I'll leave this for your sort of personal enjoyment, education. So you can actually look inside these methods really easily and find out how have we actually formatted the prompt to perform these tasks and to do that successfully. So you can, I think it's always good to actually read the prompt to understand what is the model, what exactly is the model being instructed to do. So I encourage you to look inside these, generate gap queries, search chunks from vector, generate subquery, etc. Very quickly, so after it's done that, it terminates, it then returns to this query function, and then now we're in these two steps here of synthesizing the report from all of these subqueries and retrieve trunks. And that's just more prompting of the same model. And when you've done that, then it may take 10 minutes, 30 minutes, depending on what inference service you use in the question. It will have done multiple iterations of this, this reasoning, breaking down the question into a number of steps to answer it, working out whether it should keep going or finish, and it generates a nice little report. And I've got an example here. So the question was, how has the Simpsons evolved over time? And it's put together this nice little report, sort of really covering all bases, a nice sort of conclusion tying things together. So let's go back to the slides and we'll wrap things up. So could I give a rough overview of the prompts? I think just for time, yeah, let's have a look. Yeah, so for time, I'm just gonna have sorry, I think I'm gonna have to skip like looking at the exact code, but let me just point you to, geez, now I'm a bit lost my place. Okay, yeah, so this is also in deep search, and we got subquery prompt, and you can see, so yeah, so these prompts are actually in the deep search.py file. So for example, you're an AI content analysis expert, good at summarizing content. Please summarize, da 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 da. Then there's a reflection prompt, determine whether additional search queries are needed based on the original query, etc. There's a re-ranking prompt, and there's a subquery prompt. So you can see we've got at least like 4 different types of prompting for different subtasks. So, but check out this file, and you can sort of like check them out in some more detail. But going back to the slides, let's see. Okay, so what's sort of like some of the secret sauce behind how these research agents work? Well, I think one thing is this idea of conditional computation. And so that means that the model can actually decide how much computation to do based on the current sort of like status of the model output. And so this can be done in a number of different ways. So one sort of more complex way is you could actually introduce like reasoning tokens that sort of tell the model to sort of like keep generating intermediate output, doing additional computations until some termination condition. Apparently DeepSeek doesn't use this method, but this is like a good strategy to do conditional computation. I think the second one is this reinforcement learning training. So really simple, just taking, conceptually, taking a strong base model, so like DeepSeek did, and then applying a form of reinforcement learning on very high quality reasoning data. And then there's sort of like this aha moment where the model just like starts to learn how to reason. It's not like all sort of like rainbows and sunshine. There are of course like some quite major challenges with these. And I think the first one is just the cost. So if you're using OpenAI's deep research agent, you'll have to have their pro subscription. I think it's like $200 a month. I believe they're still not covering the costs of like inference by charging that. And so one thing I discovered sort of like actually running these queries is how much inference they actually require, because firstly, these reasoning models just typically use a lot more inference, going through their like number of reasoning steps for a given prompt. But also the fact that it'll need to do multiple calls of these, many more calls than like a simple RAG system. Again, just like hallucinations, like all foundation models, like a general problem, they can be reasoning errors. So in its intermediate reasoning chain trace, if there's some sort of like incorrect step, then all the following steps could fail. And then I think that finally, to actually sort of train these reasoning models, we need to have really high quality open source reasoning trace data sets. And so that's something that people are working on so that we can reproduce some of these results from OpenAI and its competitors. Okay, so I can tell Sachi's hurrying me along. So very, very quickly. So in terms of the cost, some sort of solutions people are working on for that is specialized hardware, but also other types of reasoning. So there's an idea called continuous chain of thought that doesn't sort of like use discrete tokens to reason, but actually uses like a continuous latent variable, which is a lot more cost effective. And then like these barriers to entry, both with like the open source software and the like the data and the models. So players like Zillits and Hugging Face, we're working on reproducing these results fully open source. So then you folks can just take away the learnings with systems that work and really easily build successful research agents. So I think that's it from me. And it looks like I went a bit over time, but I think we've got 5 minutes left for questions.
Yeah, so you have a few questions, so let's just go through them. How does the vector embedding work for images? Are vectors created for pixels or image portions?
Yeah, okay. So yeah, okay. This sort of like framework that I presented is like very sort of general. All you need is some concept of embedding and some sort of like foundation model. So typically, so there are like really good open source models that can perform embedding of images, and they typically work on the whole image. They might be looking at sort of like patches, put that into like a vision transformer, and then output like an embedding for the entire image. And there's models that will allow you to sort of like embed images into the same space as text. So all of the same sort of concepts apply here. You just use a different embedding model that's specific for images or images and text. So in the iterate search reasoning cycle, is the iterate and reasoning being performed by the reasoning LLM and searched by the vector DB? So the LLM, it never actually performs an action. It just sort of gives the instruction to perform an action. So it will say, okay, search the vector database for this, and then the code will actually perform that search. But yeah, it's the vector database that is performing that similarity search. The LLM just sort of like requests an instance of tool usage. Does it need to be a reasoning model? So yeah, I think we've covered this. So no, I think it's actually probably good if many of the other steps are not reasoning models, because you can reduce the cost of inference of running the system. Is semantic search so does so yeah so Milvus has support for hybrid search, so lexical plus semantic search. With Milvus 2.5, you can implement that, and that would just sort of be like a very small modification to that vector database lookup step in the research agent. Can we choose the subquery number param? So I think this is one of those things where I think it's actually best. So we're sort of like designing the system to be like as autonomous as possible. You could sort of like hard code like a maximum number. You could, I don't know, you could like re-rank them, take a maximum. I think the simplest implementation, though, just lets the foundation model decide how many there should be. But yeah, so that's just like a design choice. I would just recommend letting the model actually decide that.
Okay, you do have a few questions in the chat. Have you benchmarked this against the OpenAI solution? And does the framework also provide tools to do web crawling to collect relevant data for the query?
Yeah, so great question. So I guess like the goal. So these different like open source deep research agents, they've had different goals, and so the goal of ours was not so much to like reproduce the specific like benchmark that OpenAI ran theirs on, but to sort of like produce a system that's like understandable. We can use it for teaching purposes. But I recommend, so check out the deep research agent from Hugging Face, where that actually was one of their primary motivations, was to achieve like a similar number or even exceed the benchmark, which they did. I think it's also just interesting to like compare different architectures for research agents. Okay, does this framework also provide tools to do the web crawling to collect relevant data? So yes, like so we've got like sort of the tools to call a number of different web crawling services. I think we're still sort of like adding that as like a dynamic tool call, but I think that's something for the near future. But you can just say, okay, here is like a domain name. I want to sort of fetch all of my data from this domain, and then it'll call Firecrawl or whatever service you're using, and then pull that in, index that, and then run your query. So great question. And I think that brings us just up to about time.
Yeah. Yeah, right at the top of the hour. So thank you guys. Thank you all so much for joining today. Stefan's put his information on the screen here if you have questions for him. We also have office hours if you want a specialized one-on-one session. The QR code for that is right here. And we also have a workshop coming up in person in Palo Alto if you are based in the Bay Area, which I did see some of you are. So
With
make sure
OpenAI.
you register for that. So thank you all for joining today, and we look forward to seeing you at our next webinar. Have a good rest of your day.
Thanks everyone for coming, and hope to see you in March for our workshop with OpenAI. Okay, take care.